Now let's study a very interesting topic called as functional equation. Um, an equation that specifies a function implicitly is called as a functional equation. So in other words, it's an equation that involves functions, right? And as mentioned here in the next line, typically a functional equation relates the value of a function at one point with its value at some other point. And finally, to solve a functional equation means that we have to find the explicit definition of the function involved in it. So since we are not given the exact expression of the function, we have to find that expression, which means we have to solve the functional equation. Now let us see some examples of simple functional equations to get an idea of this. Now here if you see, f is a function which is having a property that f of x plus f of y equal to f of x into y. So where x and y might be any 2 points in the domain of the function, right? Any two values in the domain. Now to solve the functional equation, remember that there is no direct formula as such. Like we have to observe the relation given and try to make out some patterns and try out certain guess. So here if we see, the value of a function at point x plus value of the function at point y is equal to value of the function at the product of x and y. Now here if we consider the function as logarithmic function, alright, then we will see that clearly this particular definition of the function satisfies the given functional equation. That means if we consider the LHS, that is f of x plus f of y, and as per the solution that we have found, say the f is nothing but a logarithmic function, so f of x means log x and f of y means log y, because it's the same definition. And we know as per the rules of logarithm, log x plus log y is log of the product xy. And now here we see that log operates on the product xy, so that means we can write this as nothing but the same function f but operating on the product xy, and this is nothing but the RHS. So we see that if we put f equal to the log, then the given functional equation is satisfied. So therefore we say that this particular definition is the solution of the given functional equation. So in a way we are solving a functional equation to get the explicit definition. Now let's see one more example. Now here we have f of x into f of y is equal to f of x plus y. Now here also if we guess a little bit, it will be easy to find that here we are talking about the exponential function, because if you consider the LHS, which is the product of f of x and f of y, which is nothing but a raised to x into a raised to y, and whenever we have bases common in this particular multiplication, we add the indices, right? And now once again here it is a raised to x plus y, so therefore that is nothing but the same function but for the expression x plus y. So therefore here we get the RHS, and hence the given functional equation has the solution as f of x equal to a raised to x. It's an exponential function, and here we know that of course a has to be a real number, a is positive, and a should not be equal to 1, right? Now let us go to the next example, that is f of x plus y is equal to f of x into g of y plus g of x into f of y. So now here this functional equation involves two functions f and g, as we can observe from the symbols. And if we see the pattern, that is f of x into g of y plus g of x into f of y, there is a interchanging of the functions which are operating on x and y, it will be clear that this f has to be the sine function, because we know that sine of x plus y is given by sin x cos y plus cos x sin y. So therefore, relating the corresponding terms, we see that f is a sine function, and hence it is clear that the remaining function g has to be the cos function by analogy. So therefore, f of x given by sin x and g of x given by cos x, these are the solutions of the given functional equation. So this is a kind of joint solution because it has two functions involved, right? So that's how we solve the functional equations. Now many times to solve a functional equation we may need to put some simple values of the variables involved in the functional equation, so that we get some idea about the behavior of that particular function. Alright, now let us see some of the useful results that involve the functional equations. Now we might be familiar with some of these concepts already. Firstly, if f of x plus f of minus x equals 0, then it means f is an odd function, and we know this obviously because if you take this f of minus x to the other side, we get f of x equal to minus of f of minus x, which is the definition of an odd function. But we can generalize this and write that f of a plus x plus f of a minus x equal to 0 implies that the graph of f is symmetric about the point a comma 0, right? So we know that if f is an odd function, then it is symmetric about the origin. The graph is symmetric about the origin. So in general, if you have the functional equation as shown here, that is f of a plus x plus f of a minus x equal to 0, then its graph is symmetric about a comma 0, right? Similarly, we have the second property, that is f of x minus f of minus x equal to 0 implies that f is an even function, and we can generalize this also and say that f of a plus x minus f of a minus x equal to 0 implies that the graph is symmetric about the line x equal to a. Now if the function were an even function, then the graph is symmetric about line x equal to 0, which is basically the y-axis, but in general the line x equal to a will be the line of symmetry, right? And lastly, the third observation is, if we have some function f such that f of x equal to f of x plus t, then it means that the function f is periodic, because you see that after adding t to the value of x, we get the same value of same as f of x. So that means it is periodic in nature. Okay, now let us solve one example based on the functional equations. Now here it's given that if f of x into y is equal to f of x divided by y for all positive real values of x and y, then, and also if f of 30 equal to 20, okay, then we have to find the value of f of 40. So now here as I mentioned earlier, sometimes to solve this particular equation or to find out the required value, we have to put some simple value of the variables involved. That means here if we put say x equal to 1 in the original equation, so we can write f of y, because here now x becomes 1, isn't it? So when you put x equal to 1, you get f of y equal to f of 1 divided by y, correct? Now let us take an advantage of this particular condition given, that is we are given f of 30 equal to 20. So therefore, as per the definition, f of 30 turns out to be f of 1 divided by 30, isn't it? So whenever we put y equal to 30 in the expression that we just found, we get this particular equation. But we are given that f of 30 is equal to 20, so putting that, we have 20 equal to f of 1 divided by 30. So this readily gives us f of 1 equal to 20 into 30, which is nothing but 600. So you see, we got some clue, that is we got the value of the function when the term inside the bracket is 1 is equal to 600. Right? Now we have to find f of 40. We take the help of the same equation, that is f of y is equal to f of 1 upon y. So therefore f of 40 will be nothing but f of 1 upon 40, and we know that f of 1 is 600, which is what we have found already. So therefore we get 600 upon 40. So therefore, by dividing, we get f of 40 is equal to 15. That is the answer.